Hi everybody in intermediate econ. I'm going to go over two problems from homework 3. These are problems 6 and 7. These are both elasticity problems. One is a price elasticity of demand. The other is an income elasticity. This was something someone asked about in the discussion thread. So I'm going to go ahead and solve them. And for both of them, the form is the same no matter what numbers you get, and so hopefully that's the important thing. It's getting the form and understanding the way the problem is solved. So the first problem looks at a community that has raised the price of water for high-end users to decrease the quantity of water consumed. And so the example I'm going to run with is we have a community where the price of water has gone up by 80%. Oops. And that has decreased the quantity demanded of water by 20%. And then the problem asks you to find the change in revenue. And so what we're going to do is break this down step by step to find the change in revenue. And what we're going to start with is the sort of qualitative step of just figuring out what this means, and then the actual answer. So the first thing is we can find the price elasticity of demand because we have the percent change in price and the percent change in quantity demanded. So that's going to be negative 20% divided by 80%. That gives us that price elasticity of demand. And we can already see that even though the price went up by a lot, the quantity demanded did not change much. So that tells us it's inelastic. And we can see that with the elasticity of 0.25. It's a relatively inelastic good. That makes sense, right? Water is a necessity. It's hard to get water into your pipes from a source other than your utility, so there's not a lot of substitutes. So we know already that an increase in price, we want to expect that to have an increase in revenue, right? Because remember that revenue is just price times quantity. So far, so good. All makes sense, right? How do we get the change in revenue? Well, what we're going to do is just do a little bit of more algebra. I feel like that's all this homework assignment is a lot of algebra. So we can think about this as being revenue is equal to price times quantity. And we know that we can assume that there's sort of an assumed one for all of these, even without knowing what the prices and quantities are. And the problem gives you the price, but it doesn't give you the quantity, so we can't calculate revenue on our own. We have to sort of look at the relative effect. And so what we can say is, okay, price went up by 80%, so we can call that 1 plus 0.8 times P, and then we know that quantity went down by 20%. 1 minus 0.2 Q. And so we can solve this for the overall change, and that's going to give us our effect on revenue. So we've got revenue is now equal to 1.8 P times 0.8 Q. And then we can factor out that PQ part that we sort of started with, right? And that's going to give us our effect on revenue. So we multiply 1.8 times 0.8. Oh, there's a glare there. That doesn't help. Sorry. I don't know what to do about that. So that's here. That's a little bit better. Oh, it's the glare coming from my computer. Okay, I can't do anything about that. Hi, Jack. So 1.8 times 0.8 gives us 1.44 times PQ is equal to R, which means that we can say the change in revenue is an increase of that 0.44 or a 44% increase in revenue. Does that make sense? Hopefully. I hope so. The next problem looks at coconut oil, and it gives us, got it? It gives us the demand function for coconut oil, and it asks us to solve for the use our knowledge of income elasticity to solve for the problem. So let's go ahead and do that. So we start with our general information. So we have the demand function for coconut oil is 1200 minus 9.5 times price plus 16.2 times the price of palm oil, which is a substitute good. And then we have the income elasticity here is 0.2 times y. And that's the important thing you want to remember, is that 0.2 is part of our understanding of income elasticity. It's not the income elasticity, but it's how much a change in y is going to affect q. And that's part of it. And we remember when we looked at income elasticity, we said that it's going to be the percent change in quantity demanded divided by the percent change in y, or change in q over change in y times y over q. We're going to use that because we now know that the change in q resulting from a change in y is 0.2, and then we just need to find y and q. And that's what we're going to do. We'll solve for y and q to get our results, to get our income elasticity of demand. Okay, so also given by the problem are some of our variables up here, right? So the price of, there it is. The price of coconut oil is 45 cents. The price of palm oil is 35 cents, or 31 cents. And then the quantity in this example is 1307. And so I can go in and insert those numbers into my demand function and then solve for y, and that's going to give me what I want, which is I want to solve for this income elasticity, knowing now that I have 0.2 times y over q. And one way to do it is just to go ahead and say, okay, well, this, I'll show you the way I do it, and then there's another sort of different form that you could take. But I'd like to just solve for y and then insert it into the equation. So q is 13.07, or 1,307. And then that's equal to 1,200 minus 9.5 times the price of coconut oil, 45, plus the 16.2 times the price of palm oil, plus 0.2y. All in there? Good. Okay. And then we just start solving algebraically. So I get 107 equals, and then it's 4.5 times 45 is negative 427.5, plus 16.2 times 31 is 5. That's not a 5. 502.2 plus 0.2 times y. So pull these over to the other side by adding 427.5, subtracting 502.2, and I get 32 equals 0.2 y. So I can solve for y and say 160 is equal to y. Now I can go back up here and insert that into my equation and solve for the income elasticity of coconut oil according to this paper. So now I have, let's take this and rewrite it, right? And I don't think it's the most important thing in the world to remember this notation because a lot of people use different notations. But if you can keep track of it, it's going to benefit you. Okay, so we've got y is 160 and q is 1307. So that gives us, get the calculator out, 160 divided by 1307 gives us 1.224 times 2 gives us a approximate income elasticity of 0.244 or 0.25, depending on the rounding error. I'm going to call it 0.245. Sound good? Make sense, kind of? We didn't spend a ton of time talking about income elasticities, I don't feel like. So let me know if you have any questions about them. We're going to expect all of our income elasticities to be positive for normal goods, and it's just showing us the effect of a change of income on quantity demanded. The nice thing is, so with the price elasticity of demand and price elasticity of supply, we use the slope of the demand and supply curves to solve these kinds of problems. And really, it's just the coefficient for price. And that's what we're doing here. We're using the coefficient for income instead of the coefficient for price to solve. And so it's really a very parallel problem. All these problems are being solved in very similar ways. So I hope that clears it up. I hope it makes homework 3 a little more manageable. Let me know what questions you have, and I'll see you next time.